the only way to change the state machine is to post an event. So as you remember from the definition, this particular state machine has only 4 events, and that's it. Uh, and whenever you post event, you essentially can attach download payloads, and there are 4 payloads. So every payload is code generated, and you can use any class, and it will be as many payloads as you have distinct events, right? So in our case, it is exactly 4. How to define the payload? Again, you go to the spec, right? And in the generated spec, like here, you have the payloads. They all are defined as just null PTR. And my demo is also declaring them as null PTR. So this example doesn't really do any payload, because in this example, probably there is nothing to put there to make any sense. But payload actually makes this state machine generator very powerful, because you can essentially attach the payload, and I will show where you will see it. The let me just show next methods. So this is the valid transitions graph from current state. So essentially internally, it's just using the statically generated methods, but just passing the current state. Then the internal context can be accessed using this method. So essentially, because it has to be internally synchronized to prevent any concurrent modifications, to modify it, you have to define kind of inline lambda, and it will receive the context as the like function parameter. So it's actually very simple. You can check if the state machine is terminated. This is what I was doing in the demo. Essentially, I was just looping until the state machine is terminated. This is how any simple example could be made. Okay, this is the log method. And then the following methods are all virtual. So above, there are several static methods that are not static, but they are like non-virtual, and you cannot overload them because they are part of the engine. And the virtual methods are pretty much all callbacks. The generated code has all of them defined with some simple no-op action. Usually it's just logging, like for example here, it's just invoking logging. So this is made the way that the generated class is essentially not abstract. So you don't have to overload any method to make it running. Like there is no abstract virtual methods here in this class at all. So the first group of the methods that you can overload is generated for every state, like when the machine is leaving the state, right? And this will be the callback. Then the next group is to enter the state, and this will be the enter the state with particular timer, this kind of special event. This making this unique by state and event is necessary to essentially make those methods compile properly, like resolve with the particular payload. So we really need 4 methods in our case. Like we have the transitions, and each transition is happening because there was event posted, and this particular transition entering working on timer means there was a timer event posted before, and here's this timer payload which generates it, which goes along this event. Then the next group on entering state and on entered state, entered means that the machine actually changed the state to the new state. So this event will post it right before changing the state. And this is the callback which is invoked after changing the state. So this is all on top of those events that you actually already can specialize the actions as part of the spec. But those actions are part of the model. So for example, start hungry timer exists only because in your model, you have like start hungry timer here. And those virtual methods are always generated. They are not controlled by the model. They are just provided for your convenience all the time. So this is just implementation of this method while I transition from, and that's pretty much it. You probably should know how many internal fields there are. There are some helper methods that I will not go through. And I will just show what kind of data fields there are. So first one is the thread, which is actually processing events, right? And the thread will be joined in distractor. Then there is a mutex, which protects everything else. So all other fields are fully synchronized. The thread is not synchronized because it doesn't has to be. The current state is synchronized, and that's the hard-coded structure, right? You cannot replace it. Then this event queue is where the events are stored, and it is simply the queue of callbacks. Each callback will simply invoke the particular helper for the event. This is the conditional variable where the producer has to notify the consumer that there is an event posted here to the queue, and also it has to notify when the state machine is terminating so that the event queue processor actually wakes up and exits the loop. And then there are a couple of booleans that are just needed for internal machinery. So I will not explain what exactly they are, just to keep it simple. And finally, this is the state machine context. So context, this is arbitrary class, which is specialized by the template, right? So when you instantiate, declare the state machine, you can pass this spec, and in the spec, the first field that you can have in this spec is the using, declaring the actual class which will be used as a context and store it here. So you can have some user-defined state, which is part of the machine. Okay, so that's probably it for the tutorial. So thank you very much. Let me just run the state machine one more time, and this will be the end of my demo. Thank you very much, and I hope you will start using this code. It's good if you are doing C++ and you need some kind of state machine. That's what I'm offering you under MIT license, free to use. Thank you.